What about now? So what happened is on my mic, there's a button, right? So when I was trying to fix the mic, I pressed the button and I essentially muted myself. I never used the button, so that got me. And it's clear. Wow, amazing. So this has been kind of interesting for me as, someone doing streaming. I've never had the streaming just kind of blow out like that. Um, and I really didn't know what to do. So it looks like if you start a new stream, at least some people will be able to find you again. Um, yeah, it also makes me want to figure out if I can somehow get a headphone and hear my voice while I'm streaming. That might be helpful, although that might just confuse me as well. All right, so well, let's do some chemistry here. You're looking at my YouTube live screen, aren't you? Let's try this here. Um, once I try to get my brain back around it. All right, let's go to my screen. Here we go. So we're trying to figure out what you might get here. So it's a double displacement reaction, Jason, like you're saying. And you can tell because you have a metal, a group of nonmetals, a metal, a group of nonmetals. That's going to be a double displacement. And these are aqueous, so they're already dissolved. So they're not going to magically come together. So really all that can happen is these guys going together. So we get Cu, OH, and it's OH minus. So you've got to have two of these here to balance that 2 plus over here on the copper. And then over here, the Na could go with the SO4. But again, the SO4 is 2 minus, so you're going to need two of these since they're 1 plus. So these could be the products that we end up with. And so what we want to know now, because we're really trying to figure out what the precipitate at the bottom of this beaker is. So how do we figure that out? That's the big question. Well, the way to do it is to look at solubility. So there's two ways we can do this. One is look at the solubility table like you're saying, Jason. So let's do that first then. So sometimes your teacher will give you a solubility table and then you can just look things up. That's the easiest way to do this. So here we're looking at copper 2 hydroxide. So we find copper 2, we find hydroxide, we go across I. That I, that means this is insoluble. So we can put an S after it. It's going to be the solid. And at this point, we know that's what the blue stuff is. It's the precipitate. It's that solid that fell to the bottom. If you look at sodium, sodium down here, you guys can't see that. I'm on top of it. Sodium and then sulfate, and we go across and we get that S. That's going to be soluble, so we put an aqueous. So really, that stuff that fell to the bottom, that's the solid. That's that blue stuff there in the bottom. The other way to do this is to use, does anyone know how else you can do this? In general, Na is very, very soluble. And you can also use the solubility rules. And Jason, that kind of answers your question there. I would memorize the solubility rules. So if we look at Na2SO4, the first rule is group 1 elements. They're very soluble. So Na is going to be very soluble. And sulfates, most sulfates, they're soluble too. But hydroxides, unless it's one of these group 1 elements with your hydroxide, hydroxides are pretty much slightly soluble or insoluble with a few exceptions. So that's kind of the way you can tell. You can use the table or the rules. I use the rules, and then if it's one I kind of don't know, or maybe it's like I haven't seen, I'll get a table out and look it up. So again, that's our precipitate. That's the aqueous solution. All right, let's take a look at what we're trying to get to here is a net ionic equation. So how do we know what ions are involved? So when we started out, we had our CuSO4 and we had our NaOH here. See if you can break these apart into their ions. I've already written the charge up here, but see if you can do that. Can you break these apart into their ions like they would be in water? And be careful, because you can't break solids apart. They're not going to dissolve. They won't dissociate. So leave that alone. Take a minute. Give it a try. Oh, I lost my chat. Where's my chat? Okay. So when you do a net ionic equation, first off, you figure out what you have, whether it's solid or aqueous, and then you can split it up. So you can take Cu, 2 plus SO4, 2 minus. And so, Jason, we don't eliminate spectator ions until the very end. So right now we'll do the complete ionic, then we'll do the net ionic. So here's the problem people have. This 2, it goes to this whole thing here. So we have 2 sodium ions and 2 hydroxide ions. That's right, Jason. They're called spectator ions, and we'll actually take a look at that in a minute. So 2 hydroxide ions. And then over here, don't split the solids up, because at the bottom of our beaker, that's where it's at. It's not split up. It's not dissolved. It's actually a solid. So we've got our copper 2 hydroxide. Whoops, that's copper 2 sulfate. Copper 2 hydroxide. That stays together. And then we have, and here's the other place we have problems, 2 sodium ions, because they're split up, they're separate. 2 sodium ions, and then we have our sulfate ion. And that's called the complete ionic equation. So you've got your complete ionic equation, and then we can cross out the spectator ions. But I kind of want to do the reaction one more time, because it's such a cool reaction. Let me see. Can we do it so it's easier to see? Let's go back to me for a minute. All right. Put this thing on here. And so we have, I'm going to put a piece of paper behind it here. Let's see. Let's put a card behind it. And then I'm going to drop some more sodium hydroxide in here. All right, so there it is here. Let me move my chat so I can see. There it is. And I'm going to drop more of this copper 2 sulfate in. And you can see it just fall into the bottom. It's kind of a pretty color. Doesn't show up as well. There we go. All right, so that's the complete ionic equation. Whew. Gets hot underneath that thing. No lab coat or gloves. No, Jason, you know, I like to not wear gloves in general with things like acids and bases, because then I know if I get it on me, I know that I got it on me, and I'll get it off really quick. Acids, they itch at first. Bases kind of, they're slippery. So I can tell when I get something on my hands, and I'll just go wash it off. But your eyes, you don't want to wash your eyes off. You're in the cold water for 15 minutes with water going into your eye to wash it. That's not fun. So I find that gloves sometimes mess me up when I'm pouring stuff. So unless it's a carcinogen, I don't necessarily wear gloves. Yeah, NaOH will make your skin itch, but pretty soon it starts to kind of, I feel like it hurts if it's strong enough. Acid just burns. So anyways, I have a little bit of experience there, unfortunately. So let's go over here and let's do this complete ionic equation. So we got the net. And I know like in AP chemistry and so on, and NEAT and so on, net ionic equations are really important. And they're really useful. There's a lot of chemistry here. So for a net ionic equation, I'm going to put a solid after that. Everything else would have an aqueous after it. However, you can see that these have aqueous after them. Just remember that. So let's cross things out that are the same. So I can see right here that I have a sulfate right here and right here. So I just cross that out. That's gone. I can see that I have 2 sodium ions on each side. Those are gone. And these are called spectator ions. And the reason we call them spectator ions is we have it here and it didn't change. It's still SO42 minus. It's still SO42 minus. Nothing changed. And with chemistry, if it doesn't change, then, you know, we don't really worry about it as much. So the 2 sodium ions, 2 here, we started with them. We still have them. They're just watching. They're not reacting or doing anything. Spectator ions. And often you'll be asked that specific term. They'll say, what are the spectator ions? And you should be able to tell them what they are. All right. So we have our net ionic. So if you wanted, you could just cut all that out and give you the net ionic equation. Cu2 plus 2OH minus gives you COH2. And let's actually do that. Let's get rid of all this. And I'll show you why. Because we can make sure, absolutely sure, that we're right. So when you get one of these problems on a test, here's how you tell if you did it correctly. I didn't learn this when I was taking chemistry. I learned it afterwards, and I wish I had it. So first, you make sure the atoms are the same. So you have 1 copper atom here, and what was 1 copper atom here? I don't know what happened here. Something crazy. It's been a rough night for me here with technology. So I have copper, copper, all good. Then I have the 2 hydroxide ions here, 2 hydroxide ions. And here I have a 2 plus, and 2 times 1 minus is a 2 minus. So these cancel out, and here this is neutral. So I know I did it right because all the atoms are the same and the charge is the same. All right. So we're going to wrap up almost. Let's do a little. Let's take a wrap up here with our spectator ions since we've been talking about them. So we said we started out with this copper 2 ion, the sulfate ion here, and then we had the sodium ion and the hydroxide ion. But these here, they combined and they formed that copper 2 hydroxide. And that's what's down at the bottom of the beaker. So you have sodium here and sulfate ion, it's still in the beaker. So we had sulfate ions here, sodium ions here, we mixed them, they're still just floating around. That makes them spectator ions. That's an important concept. All right. So what I would suggest, hey Jessica, thanks for dropping in and thanks for the kind words there. What I would suggest is that I'll drop this in chat, that these are a bunch of practice equations with net ionics. And so for each one, you get to practice the solubility rules, splitting things up, checking your charge at the end. So spend some time with that and you will be really good at net ionic equations. There it is right there. That's one of my big videos. Lots of people watch that. I think that we're going to wrap up there this evening. It's getting towards 9 o'clock where I'm at here in the night down near DC. And I'm going to think about what went wrong with my technology, see if I can prevent that from happening next time. I'll stick around in the chat if you have any questions for me in the chat. I'll stay around for 4 or 5 minutes and drop some links if I can help you out that way. But other than that, I think that's it. We finally did a demo here, and we got this kind of weird blue precipitate, which is kind of fun. In the description, there's a full video about this reaction if you want to watch that. Cool. Thank you, Jason. Thank you, everybody, for being with me here tonight. I appreciate it. As always, this is Dr. B, and thanks for watching.